Welcome everyone to the webinar Use of Extended Reality in Your Digital Transformation. Today we are going to present you a few results of our projects. We have a lot of projects in Flanders Make running at the moment in this topic. Here we are going to select a couple of them for you. You also see in this slide all the people and all the partners that work together with us to realize all these projects. The agenda of today, we are going to have three presentations. The first one is Smart Operator Support through AR/MR. It will be done by me, Diana.espinosa. The second presentation will be Augmented Reality in a Low Volume, High Mix Manufacturing Environment. This will be done by my colleague Steven. And the third one will be Gabriel. Presentation was ergonomic evaluation and optimization through VR. This is a very short webinar. We have only 30 minutes to present all of this. So I remind you that we have an option also to do one-on-one online session with you. If you want, we can discuss your use case. We can advise you in the best way. And you can book this webinar after this online session after the webinar. We also have some minutes left for some questions. You also can do it in the chat if you want. If you don't have time to answer all the questions, we will take our time later to give you feedback via email. So I am going to present the first one, Smart Operator Support through AR/MR. I am Diana Espinosa. I am project leader at Flanders Make. So first, I am going to explain you what is the difference between all the realities, augmented, mixed, and virtual reality. In augmented reality, you see your environment, you see your real world, but with an extra layer of information. In the virtual reality, you see a full immersive world, so sometimes they are not even logic. The person uses a helm set, and he is completely immersed in an artificial world. And the mixed reality is the combination of augmented and virtual reality. You see your real world and you can interact with some virtual or digital components. We have already some examples of augmented and mixed reality in our life. Some GPS already use this technology. You see the picture or the way that you are taking, but with some extra layer of information, some errors, some information. You also see the last app of IKEA, where you can put the sofa in your living room before you even go to the shop. Why do we need to use extended reality in the industry? The manufacturing and the industry in general is going very fast. The operators need every time more and complex knowledge. The products and the process are also more complex and variable. And the customer demands more and has high expectations. So augmented mixed reality could help to increase efficiency. The productivity will be higher also. They have simple training. You also get information to the point, and the quality in the information is just better than on paper. An important and relevant application during Corona is the remote assistance. Real-time support in these difficult times where experts are working from home or when we have restrictions to travel are having a lot of relevance for the moment. When we think about augmented and mixed reality, we imagine that we will need high investment of high devices, high technology devices, but the reality is that we can use augmented and mixed reality already from our smartphones, our tablets, or PC. Of course, we have also a large range of smart glasses that that you can use to use these applications. You also have very low budget smart glasses to very high tech mixed reality glasses. In this picture, I just show some examples of them. The mixed reality smart glasses like the HoloLens, but you also have a lot of other smart glasses that working with that. So I am going to give you three examples of application of very basic applications that you can already adapt in your industry. The first one is the remote assistance. With the smart glasses and smart devices, it's easy to support your operators remotely. You can give indications in the space, you have annotations, you can see, for example, in this picture, the expert in the other side of the screen is giving some indication to the operator who is wearing glasses. He's just saying, okay, take this part and put it there. You can go to the point information to the operator to support it. When the person is wearing the smart glasses, It has no interruptions on their work because they are hands-free. And also, you also can use this remote assistance on your smartphone, your tablet, but also on smart glasses. With the remote assistant, you also can share documents, photos, videos, so you can support as much as possible the operator at the other side of the question, the person who is on field or having some problem. The second application is the smart picking. Smart picking, you can, in the warehouses, many of you maybe know that there are a lot of projections, devices, and other devices that are used for smart picking, for order picking. I would like to make emphasis here in the smart picking with smart glasses. Warehouses are full with parts. It is crucial to pick the right product or to pick the right order, in the right order, sorry, so you don't lose time. More product variation means more products, more stock, more complexity. Smart glasses of augmented reality and smart glasses give information to the point where it is located, the amount of products it has to take, product name, etc. No extra devices are needed or long paper lists are needed. Also, the systems are easy to synchronize with your stock manager, so when the part is finished, it is also reported. The third application is the visualization of real-time information. This is an application where you combine IoT and digital twin systems. Every machine has an identity, an ID, and it can have also a QR code. The machines generate and send data to the database in local server or in the cloud. And the augmented reality devices, they can scan this QR code and get the real-time information from the machines. You can read information like of the production, actual info, what is the future planning, the status of the machine, etc. But they also can read information of sensors like temperature, battery percentage, etc. I just show you 3 applications, very easy to implement, but you also can have a little bit more out-of-the-box thinking for these applications and for these devices and applications, and you can apply them in many ways. I just put a list here. Some other questions that we get, how we solve this problem, and we just advise this kind of devices or applications. You also think this industry has a lot of potential, of course, for these applications, but actually the schools and the health and care sector, they are also adapting all this technology at the moment. And for example, for remote assistance in the hospitals, they are also using a lot now with the restrictions of amount of people in the same room and so, etc. And for the industry, you also have, of course, the make industry, but you also have a lot of industry that are adopting this, like agro industry, food industry, lab or process industry, biopharmaceutical industry, etc. At the moment, we have 2 projects where we offer advice and workshops for free. If you want to try this technology in one of your sites, let us know. We could plan first an online session, then a workshop, but you also can borrow our device and demos. If in that way you will see if this technology is for you and you experience in your life and in your real environment. We have several devices and we can adapt it to your needs if it's necessary. If you want more information after the webinar, you get the presentations and you can visit the links that I just put here. And that's it. Thanks very much for listening to me. If you have any interest in this project, contact me. I am Diana.espinosa. Thanks. So now is the turn of Steven.
Okay, thank you, Diana. Good morning, everyone. My name is Steven.Kauffman. I'm project leader in the production core lab of Flanders Make. And today I'm going to talk about augmented reality in a low volume, high mix manufacturing environment. So the needs of the manufacturing industry today is that there is an ongoing transition from mass productions to a high mix, low volume production. So batches are decreasing, but product variants actually are increasing. And this makes the life of the operator more complicated, and also the risk of making a mistake during the assembly is also increasing. Augmented reality can support operators and also technicians with digital work instructions, and that can help in order to reduce assembly errors. But today we are confronted with some limitations. So commercially available solutions do exist, but at this moment it actually requires skilled augmented reality engineers to get something working, and also the amount of effort that they need to spend in programming such augmented reality application is also quite significant. Besides that, we also need a detection of the real environment so that we can put the AR layer correctly on top of that. And typically for that, we are now using QR codes or markers, but in an industrial environment, actually, this is also not preferred. So in the Farmer Icon project, together with other industrial partners that are involved in that project, we have been working and are still working on an approach on how to achieve the integration of augmented reality on the work floor. And the first starting point is actually the CAD model, because CAD models contains already quite some information which is not only useful for digital work instruction but also for augmented reality instructions, because it actually there are the visualizations that are included already. So the first step in the process is the authoring editor. The authoring editor is it will analyze the CAD model. It will generate a first sequence of steps that the operator needs to perform. But that still doesn't contain the augmented reality application. So for that, we are using augmented reality templates that can be easily used by method engineers and operators. So the templates are based on common operations that we have seen not only in the use cases of the partners, but also in literature. And for the most common operations, some templates will be made available that can be easily tweaked by non-experts to make the visualization correctly done. But these visualizations, of course, needs to be placed on top of the real world on a correct position. And therefore, we are using the state tracker. The state tracker is another software implementation that has been built. It is monitoring the assembly at the current state, and also it will monitor the operations that an operator is performing. And the combination of that will give an estimation if a certain step is correctly assembled or not. And that information is sent together with the information or the work instructions that are enriched with augmented reality to the flow manager. And the flow manager then can decide, okay, I will show a next instruction to the operator, and the instruction is visualized on a tablet or a HoloLens or other smart glasses, but it can even be also just projection system, depending on the needs of the industrial partner. Then to give you an idea about the authoring editor, so what you see here on the left is actually the current step that that an operator needs to perform, and this is analyzed based from the CAD model. Some visualizations are also automatically done, so based on the detection, okay, this is a part that we have to insert, so in this case there's a screw, and this is the direction that we have to turn it. So actually that are already different kind of visualizations that can be automatically generated. And then in the middle step there, a method engineer or an operator, depending on the company itself, who is making the instructions, they can tweak all these kind of parameters. In this case, there's pick and place. So we can define the pick position, and we can define the place position. We can also define if a specific tool needs to be used, and also visualizations can be placed on top of that. So just by using some tick boxes, we can easily get the information of the operator to make the operation or the instructions clear. Another thing that is not available in the CAD model are additional steps, like for instance gluing or surface treatment of lubrication. And for these kind of steps, we need to introduce manual operations, but also for that we have foreseen a user interface so that an operator or a method engineer can intuitively modify the surface that needs to be treated, or it can define a trajectory that needs to be followed by a specific tool. Then in the next slide, I will show you a video of an operator who is wearing a HoloLens and is doing the assembly. So you will actually just see the recording of the HoloLens. Also, to give you some information, you will still see that there is a QR code available or a marker available in the space, but we are using this actually to identify the workplace and for the initial visualization, so that to make sure that the augmented reality layer is placed correctly. It's not used for identifying the objects that are going to be assembled. So in this case, what you will see is that the state tracker, so the green rectangle that you will see, is identifying the object that we need to pick up. So in this case, we have chosen for just a rectangle, but actually we could also have chosen for a visualization of the object itself. And then afterwards, it will give you an animation. Okay, this is where you have to put the part that we are going to assemble. Then the state tracker has detected that we have put the part on the correct position and then will automatically inform the operator about the next instruction. And in this case, we need to take a part on one of these boxes. So there are two possibilities, or the operator is pointing to a box to get an ID in which box he has to take the part, but he can also just go and grab with his hand into a certain box, and then also it will be highlighted if that's the correct box or not. And then what is also useful is that there is a kind of ghost visualization where you will see actually, okay, this is the already assembled part, and this is where the part that needs to be inserted into the object, in which location it should be put. So just to give you an idea of what we have been doing and how we have used the approach in one of our proof of concepts. So that brings me to the last slide, and that's the conclusion. So we mentioned that, augmented reality now is taking a huge amount of effort to implement. So in this case, with this approach, we can reduce significantly the implementation effort. And that because we are using templated visualizations with parameters that can easily be modified or tweaked by non-experts. We used some markers, but they are only used for the identification and the initialization, so there are no markers used for part detection and or tracking. And the state tracker is able to detect the operations and the status of the assembly and can send automatically a trigger to the next instruction for the operator. So that was my part of this webinar. So if there are still questions, you can always contact me. My email address is listed here. And now I give the word to Gabriel.
Thanks, Steven. Now is the time of Gabriel.
So, good morning, everyone. Thank you for the presentation, Steven. So today I will talk to you how we can exploit VR in order to improve the ergonomic of industrial environments. So the first question is why? So why we want to improve the ergonomics industrial environments is first, not just because of the well-being of the operators, but also because it costs a lot of money. So for example, just in Flanders, it costs about 8 billion a year because of absenteeism of people who have problems in their back or in another part of their body. So ergonomics is an important problem for the companies. So the second question is how we can help them. So there are two possibilities. One possibility is a corrective solution. So when the work cells are already developed, one of the things that we can do is that we can improve these work cells by analyzing them if they are good or not. The other possibility is to build the work cells in a good way, in a predictive way. And is this where we want to focus today, and more particularly, how we can use VR and augmented reality to help during the design of a work cell. So I will explain you more or less how is the process of the design a work cell based on the models. So here we have a simplified model with a simplified actions that we have. So for example, here you have in the left an operator that have to push 2 different buttons. And the model will tell us how much will be the ergonomic impact of those actions. And thanks to an optimization algorithm, we arrive to change the position of the work cell to reduce this ergonomic impact. So how VR will help us? VR will allow us to better visualize and to test how the outcomes of these optimizers are good or not. So to explain you more or less how it will work, this is we create here in the left, you can see we will create a workplace layout. We will perform some actions. And based on the headset, we will measure the position of the operator, or also using the captive suit. So it's a set of inertial measurement units that allow us to measure the joint angles in the operator. With each of these 2 systems, we can estimate the body position of the operator, and then based on these positions and the loads that they are taking, we can compute the ergonomic loads of each actions. So when we know the ergonomic load, we can take these values in order to improve and modify the work cell to make it more comfortable for the operator. So to better visualize what we are doing, here we have one use case. Is one use case that we developed in collaboration with Albert. It's not so complicated, it's just one table. But if you can see here, you can already visualize in advance how would be the process of assembly of their crushing machine, one of the crushing machines that they use they are producers of the smoothie machines. So they have a crusher that takes the fruit and make the juice out of it. And here you can see how it will be the process of assembly. And for example, at the very end, we try to simulate something that can happen to the operator, that he let fall one key, you will see at the end. And you will see that these kind of actions that are a little bit outside of the normal actions have a higher ergonomic impact. Just to see here, the numbers that you see here are the ergonomic impact of each action. So you can see more or less how ergonomic or anergonomic is each action for the operator. And this virtual reality allows us also to validate the model, because if the value is high and the operator doesn't feel it, maybe something wrong with the model. So the virtual reality helps us a lot to validate our developments. The second model is something that you can see here. We will not see the eyes of the person who is in the virtual reality, but we will see how is the process of reconstruct the motion and how we compute the motion of the operator. So as I told you, we have 2 possibilities. One is the inertial measurement units. They are reconstructing the motion of the body here, and then we have the headset that allow us to see the position of the head. You will see here this ongoing process. There is a little bit of drift between 2 systems, but you can see already that we can already see how the operator will move. So here is the operator is performing an action. He is taking one compressor. Still, I saw there are some drifts in some areas, but yeah, we can already know how the operator will have to move to perform a specific action. So to finalize this presentation, I want to present some conclusions. So the conclusion is, what is the added value of virtual reality when we are designing a work cell, and more particularly an ergonomic work cell? So the first is that it allows the designer to better visualize the work cell that they are doing. So it's better to see how will be the work cell once it's built. The second one is it allows us to test our models. It allows us to validate the outcomes of the ergonomic models that we are developing. So if something is ergonomic in the model and is unergonomic in the virtual reality, we can have some questions with that respect. And finally, the virtual reality can also help us training the operators to perform the tasks in an ergonomic way without putting the operator at risk or if it's not necessary. So thank you for your attention. If you want more information about this project, please contact me. Here are my coordinates.
Thanks, Gabriel.
And I will put my video.
I am going to share last presentation. So now we have 5 minutes left for questions. I saw one, Tris, you can help me with the questions if they are coming because I don't see it anymore. Yeah. But there was a question about if we could see the same that Steven showed with the HoloLens on augmented reality glasses. And I think, Steven, you are in this project, you are also using HoloLens, but also other smart glasses. Maybe you could give an explanation about it.
So yeah, we are actually, as also shown in the slide, we are focusing on many 3D devices. So we do have some experience or do some testing with the HoloLens, but we are also looking at other smart glasses, be it, for instance, because Prosthetics is also a partner in the project with the Iris Stick or with the tablet or with just projection systems. So yeah, that's actually, and yeah, the visualization itself, well, it's actually also depending on the company itself, because some companies also mention that they need to have safety glasses, that the operators have to wear safety glasses when doing the assembly. And then yeah, it's also at this moment there are not a lot of devices available that have safety glasses foreseen or have it available. So that's also at this moment still a limitation of these smart devices.
Thanks, Steven. I don't know, Tris, if some questions are coming in.
For the moment, there are no other questions. Wait, there is one. Latest iPhones have LiDAR technology. Do you see any applications for merging both technologies?
Multi-point technologies. The devices, smart glasses devices like Android and smartphone and iPhones, some of them are, the applications can be used in some of them. We have to really check case by case which one is the one that you want to try. But there are a lot of applications that run in both systems, so that iPhones will not have a problem.
I assume the LiDAR question was more related also to the positioning or something of the objects, or
Menno, if you want, you can unmute yourself to ask the question.
Yeah, can you hear me now?
Yeah.
Yes, you can hear.
Yeah, it was more the idea to create indeed 3D content for augmented reality with the LiDAR scanner. It's just a broad question if you have thought about the possible applications of this LiDAR technology in smartphones.
Not at this moment, or at least not in one of my projects, but maybe the others did.
No, we are not working with this technology for the moment. Also in our projects. I don't know, maybe we have...
Yeah, no, we are working with that technology, but more in related to motion products. With where the positioning of the obstacles are in case of EGVs and so on.
Okay.
And one of our partners is working on measurement tool using the LiDAR sensor from the iPhone. So with his AR environment, he can measure real-world packages instead of having to measure them manually, for instance.
Thanks. Thanks for clarification, Menno. I don't know if it's answered your question.
Yeah, thank you.
Yeah, thanks. Thanks, Sonia, for helping.
Okay, so Ben Mai gives the idea would be very interesting to convert point cloud to model with semantics, recognize tools, consumables. Any thoughts about that?
Maybe Steven, you can answer that.
It's
yeah.
It's basically a follow-up. Yeah, it's basically a follow-up on the LiDAR remark. If you have a point cloud, you don't know necessarily what the parts are that you see in the 3D model, and you do need that for either your VR or your AR. So, but that is technology that is really not available at this moment. So, might be an interesting research topic.
Yeah. Okay, thanks. We are going to note it down. Dries, I don't know, but it's 11:30.
There are still 2 questions left. Maybe we can handle them and then close the meeting.
Okay.
So a question from Thierry Coutelier. Could you please give some more about the assembly state tracker? Is it AI powered?
Well, it's actually a combination. So indeed, we are using some AI technologies, and yeah, you're already mentioning, I see in the comments, YOLO. So indeed, what we did actually is making from the CID model, we are generating images. So we have a synthetic image generator, and based on a data set that is created from that, we will train a model and using YOLO in order to detect some parts. But it's also depending on the use case, because also we saw that in specific situations that it gives quite good results, but also in other situations it gives not that good results. And therefore we are actually using a combination also with hand tracking, tool detection, the position of the operator. It's actually a combination of different things. It's also made in a platform where we can easily plug in new kind of detection algorithms. And based on that, the state tracker is actually built.
Okay. Then last question from Yolanda. Have you already investigated the acceptance of these techniques by the operators?
Of all of the techniques, in the first presentation, they are all basic techniques that they are actually already used in production. So there are a lot of operators have accepted. But for the projects of Steven and Gabriel, maybe they can comment. Steven?
Yeah, I can comment right now.
Sorry,
so
Gabriel.
we have some discussion with industrial partners concerning this issue. So at the moment, most of the industrial partners focus in the first way to solve ergonomics. So it's the corrective way to solve ergonomics, because they already have the work cells. And what they said is that they want to see how it works, the model-based ergonomic design, in order to start doing that. So it's a little bit of they are a little bit skeptic on what can go out from this. It's something that is not being done a lot outside. So what we are trying to do with this project is to show them how we can improve the ergonomics of their work cells. And I think that when we show them, it will be useful. It will be used in the industry.
Thanks.
Steven, something to comment there?
Well, yeah, similar to Gabriel, I think also we had discussions with the partners about, okay, what do they really expect from augmented reality? And I also think it also depends on the use case, because some operations takes more than 8 hours, and then wearing a HoloLens for 8 hours, that's also not feasible. So then we focus more on the critical steps in an assembly. So yeah, it's really depending on the use case, but that there is a need for more informed of augmented reality on the work floor. I think that it's clear. But also the devices are lagging a little bit behind. I think the HoloLens at this moment is the most advanced available device. But yeah, we also would like to see more devices that are capable of doing this with a better ergonomic and all these kind of things. So hopefully the future will bring that.
Thanks, Steven. There was another question from Thierry, but he said that he got his answer, maybe in the just question of the answer of Steve. So Dries, I don't know, but do you?
Yeah, I think we can finish, and I will send the presentation and the recordings of this meeting afterwards to all the participants.
Thanks very much for listening to us. And if you have any question, don't hesitate and send us via email. We will answer as fast as possible and the best way as possible. Thanks very much.